couple. The moment produced by by two equal, opposite, and non-collinear forces is called a couple. Couples have certain unique properties unique properties and have important application in mechanics. Consider the action of two equal and opposite force F and minus F at distance D as shown in this picture. For example, consider this picture for an example for a couple. Force F and minus F equal, opposite as non-collinear. These two forces cannot be combined into a single forces because their sum is in every direction is 0. Sigma F is 0 in any direction. Their only effect is to produce a tendency of rotate is tendency of rotate the combined moment of two forces about an axis normal to their plane and passing through any point such as O in their plane in this picture is the couple M. This couple has a magnitude of, if we want to calculate the couple F, this multiplied to A plus D minus F multiplied to A, which is FD. FD. Its direction is counterclockwise when viewed from above for the case illustrated. In this case, as we can see, the direction of the couple is counterclockwise in this direction because F is also F equals to the minus F in magnitude, but the distance of the positive m is greater than the distance for the negative force. Note especially that the magnitude of the couple is independent of the distance a, which is located the force with respect to the moment center O. It follows that the moment of a couple has the same value for all momentum center. Have the same value for all momentum center. Very important for couple. We can also use vector algebraic method. In the vector algebraic method, consider this picture for vector algebraic method. We may also express the moment of a couple by using vector algebra with the cross product notation of the m equals to r cross product to f. For two type of the forces, Ra and Rb are the MO. Ra clockwise is positive, Ra multiplied to F and minus plus Rb multiplied to minus F. F Ra Rb to F. From the vector rules, Ra Rb equals to R, MO equals to R multiplied to F. Here again the moment expression contains no reference to the momentum center O and therefore is the same for all momentum center. Same for all momentum center. Thus we may represent M by a free vector as shown in the picture here C, where the direction of M is normal to the plane of the couple and the sense of M is established by the right hand side. Because the couple vector M is always perpendicular to the plane of the force which constitutes the couple, in two-dimensional analysis we can represent the same of couple vector as clockwise or counterclockwise by one of the convention pictures shown convention vectors as shown in this picture. Later, when we deal with couple vector in three-dimensional problems, we will make full use of vector notation to represent them, and the mathematics will automatically account for their sense. The equivalent couples are some of another description for couple equivalent. Equivalent couples. Changing the value of f and d does not change a given couple as long as the product fe remains the same. Take note changing the values of F and D. Does not change a given couples. As long as the product FV remains the same. Likewise, a couple is not affected if the force acts in a different but parallel plane. A couple is not affected if the forces act in a different but parallel plane. This picture shows 4 different configurations of same couple M. Consider this picture. Different configurations of same couple M. In each of the 4 cases is 1 FD. Case 2 also FD. FD and 2F multiplies to 1 second of D equals to FD. In 4 cases, in each of the 4 cases, the couple are equivalent and are described by the same free vector which represents the identical tendencies to rotate the body M in these symbols. The next section is about force couple system.